The modern food system operates on a scale that is often hard to imagine. Consider the humble egg. Many of us crack one or two for breakfast. We might use a dozen for a weekend baking project. But what about the eggs in your store-bought mayonnaise? Or the liquid eggs used in commercial bakeries that produce thousands of cakes and pastries daily? The numbers become truly staggering. Did you know that some industrial facilities are designed to crack over 100,000 eggs, sometimes even up to 120,000 every single hour? This is not a misprint. It is a daily reality in the food processing world, a constant flow of eggs moving from shell to product, largely unseen by the average consumer yet essential for the food we eat. This immense volume is a direct response to our collective appetite. We live in a world that demands convenience and consistency. Fast food chains need perfectly uniform egg patties for their breakfast sandwiches, served to millions. Food manufacturers require vast quantities of liquid egg for their recipes, from noodles to ice cream. This demand cannot be met by hand-cracking eggs one by one, as you might do in your kitchen. The sheer logistics would be impossible, the labor required would be enormous, and the cost would make many everyday products unaffordable. This simple truth has pushed the food industry towards remarkable feats of engineering and automation to keep pace with this relentless demand. The journey of an egg from the farm to a processed ingredient is a fascinating, if somewhat invisible, part of our food chain. These eggs arrive at processing plants by the truckload, sometimes millions arriving each day. They are destined not for supermarket cartons to be sold whole, but for a different path. They will be transformed into liquid whole eggs, or separated into yolks and whites, becoming foundational components for countless other food items. This transformation happens quickly, efficiently, and on a scale that dwarfs any traditional kitchen operation. The system is built for speed and volume, ensuring that the river of eggs keeps flowing without interruption to meet the constant needs of manufacturers, and ultimately us, the eaters. Understanding this scale is crucial to understanding modern food. It helps to explain why certain foods are so readily available and relatively inexpensive. It also highlights the incredible engineering that goes into feeding a growing global population. The act of cracking an egg, so simple for an individual, becomes a complex industrial process when multiplied by millions. This process is powered by specialized machines, technological marvels designed for one specific repetitive task, executed with incredible speed and precision. Without them, many of the food choices we take for granted would simply not exist in their current form or at their current price point, changing the landscape of our supermarkets and restaurants. To handle such an enormous quantity of eggs, the food industry relies on highly specialized machinery. These are not your average kitchen gadgets. They are industrial-sized titans, often constructed from stainless steel, gleaming under the lights of processing plants. Among the leading names in this field are machines like the OvoTech UDTJ500 and the Sama CC200. These are not just egg crackers, they are sophisticated egg processing systems. The OvoTech UDTJ500, for example, is renowned for its high capacity, capable of breaking tens of thousands of eggs per hour. Imagine the sound and the sheer mechanical ballet of such a machine in full operation, a constant stream of eggs meeting their precisely engineered end. The Sama CC200 is another example of these powerful automated systems. These machines are designed for continuous operation, often running for many hours a day, day after day. They are built for durability and efficiency. Their primary role is to take whole eggs, crack them open, and often separate the yolk from the albumin, the egg white, with remarkable accuracy. Some models can even detect blood spots or other imperfections, diverting substandard eggs from the main processing line. These capabilities are far beyond what human hands could achieve at the same speed and consistency, especially when dealing with volumes that can reach millions of eggs in a single week at one facility. These machines are typically found in large-scale food processing plants. These are businesses that supply liquid eggs to bakeries, pasta makers, mayonnaise producers, and companies that create pre-made meals. Think of the powdered eggs in cake mixes, or the liquid egg whites sold in cartons at your grocery store. These products all begin their journey in facilities equipped with these powerful egg-cracking behemoths. The investment in such machinery is significant, meaning they are usually operated by major players in the food ingredient supply chain, companies whose entire business model revolves around processing eggs at a massive scale for other food manufacturers. The design of these machines is a testament to focused engineering. Every component, from the egg loading systems to the cracking knives and the separation cups, is optimized for speed and hygiene. The goal is to maximize yield, getting as much usable liquid egg out of each shell as possible, while minimizing contamination and downtime. They represent a critical link in the chain that brings egg-based products to our tables. Without these giants of the crack, the sheer volume of eggs required by the modern food industry would be an insurmountable challenge. making many common food items significantly more expensive or simply unavailable on their current widespread scale. The process begins with the loading of eggs. Trays of eggs, often holding dozens at a time, are fed into the machine. Some systems use vacuum lifters or conveyor belts to gently transport the eggs towards the cracking stations. The design prioritizes careful handling to prevent premature breakage, which could lead to product loss and contamination. Once inside, the eggs are typically oriented, often with the pointed end down, to ensure a clean break. This attention to the initial stages is crucial for the efficiency of the entire automated process, ensuring a steady and manageable flow of eggs into the heart of the machine. Each egg is individually handled by the mechanism, despite the high throughput. Next comes the critical moment, the cracking. Specialized mechanical hands or knives make a precise incision or tap on the eggshell. This is not a brute force smash but a controlled fracture. The machine then gently pulls the shell halves apart. The contents, the yolk and the white, fall into collection channels or individual cups below. If the machine is designed to separate yolks from whites, this happens immediately. Often the yolk is caught in a specially designed cup that allows the white to drain away into a separate channel. This separation needs to be incredibly precise to meet the quality standards for pure yolks or pure whites, which are sold as distinct ingredients. Quality control is often integrated into these advanced systems. Some machines use optical sensors or cameras to inspect the liquid egg as it flows. These sensors can detect shell fragments, blood spots, or other undesirable elements. If an imperfection is found, that particular batch of liquid egg can be automatically diverted from the mainstream, ensuring that only high-quality product moves on to the next stage of processing. The empty shells are typically ejected from the machine through a separate chute, collected for disposal or sometimes even for use in other industries such as animal feed or soil conditioning, minimizing waste. The entire operation is a marvel of synchronization and speed. Hundreds of eggs can be moving through different stages of the process simultaneously. From loading to cracking, separating, and quality inspection, each step is automated and optimized. The machines are designed for easy cleaning and sanitation as hygiene is paramount in food processing. Stainless steel surfaces and accessible parts allow for thorough washdowns to prevent bacterial growth. This automated process ensures a consistent product, hour after hour, day after day, far exceeding the capabilities of manual labor in terms of both volume and uniformity, which is precisely what large-scale food production demands. The most significant benefit of these egg-cracking machines is undoubtedly their efficiency. The ability to process up to 120,000 eggs per hour, as some high-end models can, is transformative for the food industry. This incredible speed means that vast quantities of liquid egg can be produced quickly to meet demand. This leads to reduced labor costs, as a single machine can do the work of many human egg crackers. Furthermore, automation brings consistency. Machines crack eggs in the same way every time, leading to a more uniform product, which is highly valued by food manufacturers who rely on precise ingredient specifications for their recipes. Hygiene is also improved, as automated systems can reduce direct human contact with the food product. However, there are also potential downsides and considerations. The initial investment in such sophisticated machinery is very high. These are complex pieces of equipment that require significant capital outlay, making them accessible primarily to large corporations. Maintenance and repairs can also be costly, and may require specialized technicians. While automation reduces the need for manual egg crackers, it can lead to job displacement in that specific area, though it creates other jobs in machine manufacturing, operation, and maintenance. There's also the risk associated with any centralized, high-volume system. If a contamination event occurs, it could affect a very large batch of product, potentially leading to widespread recalls. For the food industry, the overall impact of this automation is overwhelmingly positive in terms of production capacity. It allows for the mass production of egg-based ingredients that are fundamental to countless food items we consume daily. This scale helps to keep the prices of these items relatively stable and affordable for consumers. Without this level of automation, the cost of producing items like mayonnaise, baked goods, pasta, and many convenience foods would likely be much higher. The ability to source consistent, high-quality liquid egg products allows manufacturers to streamline their own production processes, contributing to overall efficiency in the food supply chain. For consumers, the significance lies in the availability and affordability of a wide range of foods. While the inner workings of an OvoTech UDTJ500 might be invisible to the person buying a bottle of salad dressing, its existence plays a role in that product being on the shelf. The downside is perhaps a further disconnect from the source of our food, as industrial processes replace more traditional methods. However, this automation is a key component in the complex system that feeds billions of people. These Eggs-traordinary machines are a clear example of how technology is employed to meet the immense demands of the modern global palate, ensuring that eggs in their many processed forms remain a staple ingredient across the world.